Good morning, Chippewa Hills High School Chemistry 1B students. Here is a short little YouTube going over the corrections for the homework from page 211, questions number 10 and 12. Question number 10 asked you to balance the following equations. So letter A, we have SO2 plus O2 yields SO3. Again, it doesn't really matter where you start. I just tend to always start at the left. So I have one sulfur here, and I have one sulfur here, so that looks good. So I start to look at my oxygen here, right, and I have 4. And here I have 3. So that's kind of an odd number. So again, this is kind of one of the more difficult ones potentially to do. So the problem is whatever I do to my oxygen here, it's also going to affect my sulfur. So since ones don't work, I'm just going to kind of trial and error here and try a 2. Okay, so if I put a 2 here, because of the sulfur, I have to put a 2 here. So let's kind of see where we're at now. Okay. So when I look at myself at where we are at now, I have 2 sulfurs here, and I have 2 sulfurs here, so that looks okay. For oxygen, I have 4 oxygens here, plus 2, okay. And over here, I have 2 times 3, which is 6 oxygens. So I have 6 oxygens on the left and 6 oxygens on the right. So now this is properly balanced. All right, looking at letter B, Fe2O3 plus H2 yields Fe plus H2O. So again, I just tend to start on the left. So I have 2 irons here, and I only have 1 here. So I need a coefficient of 2. I have 3 oxygens here and only 1 oxygen here. So I need a coefficient of 3. I have 2 hydrogens here and I have 6 hydrogens here. So to get 6 hydrogens on the reactant side, I need a coefficient of 3. So again, I'm going to check and confirm, but I have 2 irons here and 2 irons here. Okay. I have 3 oxygens here and I have 3 oxygens here. I have 6 hydrogens here and I have 6 hydrogens here. This is properly balanced. Letter C, we have P plus O2 yields P4O10. Again, I start my phosphorus, I have 1, and I have 4 here because of the subscript, so I need a coefficient of 4 in front of phosphorus. When I look at my oxygen, I have 2 here, and I have 10 here. So to get 10 on the reactant side, I need a coefficient of 5. Checking now, I have 4 phosphorus, and I have 4 phosphorus. I have 10 oxygen, and I have 10 oxygen, so this is properly balanced. Letter D, we have aluminum plus nitrogen yields aluminum nitride. Again, if I just start on the left, I have 1 aluminum, I have 1 aluminum, so that's fine. I have 2 nitrogen, and I just have 1 nitrogen here, so I need a coefficient of 2, which means now that my aluminums have changed because I have 2 aluminums now, and I only have 1 on the reactant side, so I need a coefficient of 2. I think it's balanced. I'm going to check. 2 aluminums, I'm good. 2 nitrogens, it's balanced. Question number 12. How is the law of conservation of mass related to the balancing of a chemical equation? Again, the law of conservation of mass says that atoms can't be created or destroyed, they're just rearranged. So how is that related to balancing our chemical equation? Remember, this is what makes us atom counters, or is making you guys atom counters. because the mass of an atom doesn't change in a chemical reaction, we can just count that we have the same number of all the elements on both the reactants and products side of the equation. Okay, so again, that idea is that our number of atoms has to be equal on both sides of the equation. Your textbook answered it this way: when balancing an equation, the number and kinds of atoms in the reactants equals those in the products. Thus, atoms and mass are conserved. All right. Thank you. Have a good day.